I know you're probably growing sick of vectors and all these properties and cases, and they seem like very pathetically easy. Why does it need all this fuss? I know that seems like it, but the good news is we're almost done. Now we're moving on, I think, to our sixth case. No, the seventh case even. Oh, sixth case, yes. I think. Yeah, so we're moving on to our seventh case, which is good news. Oops, I can't erase this. Let me just erase it normally. Yeah, so we're moving on to our seventh case, which is a bit different because we're trying to express vectors as a straight line equation. In order to do so, I want you to first recall with me what a straight line equation has special about it. That would be its expression or its equation, which is the y equal to mx plus b. Now, in case of a straight line, let's do this in blue, a normal straight line, what we're doing is we're talking about the slope, and here what we're doing is we're talking about the y-intercept. It was this simple, this easy. All you needed to know is understand what these stand for and then apply it to every straight line you do. Now we're going to do the exact same thing for vectors, but with vectors the different thing is going to be what these stand for. They'll be close to. Now if we're doing vectors, we're going to have our y to be the vector as it is, the whatever vector we're trying to express in terms of, and then we're going to have the slope be, our slope is going to be something, well, we've already discussed it. When we talk about slope in terms of vectors, we're talking about the ratio between I and j. So we want the slope here is going to be any vector that is parallel to our vector because they're going to have the same ratio. So in other words, our m would be it's a vector. Oops, let me get back to the application. So yes, it's going to be a vector parallel to our, let's say this is going to be C equals to, and yes, so a vector parallel to C. And then our x here was, yes, this became our y. So yes, our x here, no, I have a better idea so you'd see what I'm talking about. Let me write it out. Okay, so we're going to call our y here, we're going to call it r instead of y, just for the case of, for the sake of so you know that you notice the difference. And our m is going to be any vector a. Let's say any vector b. You understand now. This is our vector r. You can say the difference between this and this is the small arrow on top. And then we know that b is going to be any vector parallel to our vector r now. And that's it. Here what happens next is that we know that x here was sort of a parameter. In case of our xy plane, we just took any number on the x and that was our parameter. It's something we express in terms of. Here it's going to be the same. It's just we're talking about any parameter, any counter, that is going to be t. Because we always, when we discuss parametric equations, we said our parameter is going to be t. So here is going to be the same. If you notice, there's no arrow on top of our t because it's not a vector. It is just a scalar parameter. It doesn't have a direction. And then we're going to have our plus again. And instead of our b, instead of the y-intercept, here is where the difference comes in. Let me just do this. So we have vectors. This is our vector. This has to be parallel to r. This is our parameter again. And then we're going to add. And then instead of the y-intercept, we're going to have a position vector that r passes through. Now, why is that? Well, because when we're doing vectors, we're talking about a limited magnitude that does not necessarily cross the y-axis, and what we do is that we do not give a general straight line equation for the vector. It's more of just within that limit, you know. So when we're doing it, we're going to be relating, yes, still to the origin, still to the where it intercepts our y, but we're going to do it by relating it to a vector. So here we're going to have, instead of v, a vector a that r passes through. Now this might sound confusing, but as I said, when you learned about straight line equations, all you had to know is that y equals to mx plus b, where m is the slope and b is the intercept. Now all you need to know for vectors is that r is equal to bt plus a, where b is a vector that is parallel to our vector, and a is going to be a position vector that our line or our vector crosses. Now, in order to make all this a bit clearer, I'm going to instead give you an example. So here is the example I have for you. So here we're given that we're asked to actually find a vector equation of the straight line which passes through point A, which has a position vector that is given as 3i minus 5j plus 4k. Again, when we have a k, we're talking about 3D vector. It doesn't make any difference except that k. And then it's given to us that, and it is parallel to our vector, to the vector 7i minus 3k. Now, how can we find the straight line? Well, what we write first is that we're going to write our equation. R equals to b into t plus a. We know that r is going to be our vector, so we're going to keep that as is when we're solving. We know that b is going to be a vector that is parallel to our vector, so we're given that one. It's 7i minus 3k, so let's just write here 7 and here minus 3. Oh, this is 0, just so let's just write the 0 so you don't always remember. You go for first I, then j, then k, and this is going to be minus 3. And we know that the parameter is going to be just t, and then we are going to add to that a, which we know is the position vector of a point that the line passes through, and we're given that it passes through point A here, which has this position vector, and we're going to write it out as 3 minus 5 and 4. And by that we actually solved it technically, almost. You can join the two matrices by saying that it's 7t plus 3 into, and here it's minus 5, and here it's 4 minus 3t. And by that you have your the general equation for r, where in terms of t, where t is just a parameter you're expressing in terms of. And that solves the equation. That's how simple